Hello fellow explorers, my name is Tony Toppy and today we're going to be talking about the planet Mars. So Mars is about the fourth planet from the Sun and sits right in between the Earth and Jupiter. Or if we were to look at this animation here we see Earth with the moon orbiting around it, and here's the planet Mars, and right there is the planet Jupiter. So if we were to measure the distance in astronomical units, Mars is about 1.5 astronomical units away from the Sun. Mile-wise, it would be about 142 million miles away from the Sun. So size-wise, Mars has about 1/10 the total mass of the Earth. And diameter-wise, Mars is significantly smaller across than Earth. Earth comes in at about 26,000 miles across, whereas Mars is 4,222 miles. Still definitely bigger diameter-wise than the Moon. It's probably roughly over twice the size of the Moon's total diameter. So the surface of Mars is thought to significantly change over the billions of years. A lot of the data has actually shown that liquid water may have existed in the past. But right now, it's very dry and rocky, and it's covered by this thin layer, or this fine layer rather, of iron oxidized dust, which actually gives the planet that red hue that we've come to know. Surface temperature-wise, Mars is below the freezing water point. It sits on average at negative 81 degrees Fahrenheit, whereas planet Earth runs on average at 57 degrees Fahrenheit. So the most fascinating fact that I came across were the major differences in atmosphere. So Earth is over 100 times more dense than the atmosphere on Mars. And I actually had the opportunity to attend the ASU Earth and Space Open House this past Friday night, and one of the tables had a speaker that actually used the example of putting your hand out of a moving car window. When you do that, you usually feel all this force and pressure from the wind. Well, if you were to do that same thing on Mars going just as fast, you would essentially feel nothing. The speaker said that you'd have to go like 1,000 miles per hour to feel anything along the same effect. So I heard that and definitely thought that is a point of interest. So the mission that I chose to research was the Curiosity rover. Curiosity mission happened in November 2011, and it involved this particular rover. So this image actually points out some of the features that the rover had and what it did. I know it's kind of small, so I'll just highlight a couple of these features. So this top part here was a color camera, and this robotic arm right here and right here had the ability to drill holes and pulverize rocks. This portion right around here, right around the middle area, was a weather station that could measure environmental variables and give daily reports. And this area right here had an active neutron spectrometer. So that helped search for the water in the rocks and soil that was beneath the rover. I guess the biggest finding that the Curiosity rover found was that ancient Mars likely had the right chemistry to support living microbes. Should humans go to Mars? Personally, I say yes. I think by going to Mars, it would really result in a lot of major milestones, as well as a lot of different types of progress. First and foremost, I think that we would have major developments in things like recycling and solar energy, and give us a new, different take on different types of food production. Aside from that, I think we would have the opportunity to learn more about what happened to Mars over the course of time. And lastly, just how to potentially sustain life on a planet outside of our own, and learn how to really overcome some of the challenges and obstacles that are faced or would be faced in doing that. So here are some of the references that I used in making my presentation, and that's it. Thank you so much for watching.